InterFET, the world's largest supplier of JFET products. In this video, we will demonstrate how to reduce noise by adding JFETs to the front of an op-amp. Here we can see a representation of the APX525 audio spectrum analyzer we will use. It has two channels and an onboard signal generator. The test results will be stored in Excel files in a computer attached via USB. The output of channel 1 will be connected to an op-amp module with a TL071 wired as a non-inverting amplifier with a gain of 100 that is contained in a shielded enclosure and connected via BNC cables. We will compare this to another module that has the same op-amp but with a JFET differential amplifier added to the front. 3 JFETs are used. Q1 and Q3 form the differential amplifier, while Q2 is used as a constant current source. RV1 is used to correct manufacturing differences between Q1 and Q3. We will first use the signal generator in the analyzer to sweep a sine wave from 1 Hz to 80 kHz. This frequency sweep is applied via J6 and J7, where it is amplified by the two modules and then returns to the analyzer via J4 and J35. The result is sent to the computer and stored in a gain file. The sine wave is turned off and the inputs to the modules are shorted to ground. When the analyzer samples the analog inputs, it records circuit noise and stores those values in a noise file. This results in an average of 10 samples of the audio band by the analyzer. We will repeat the noise sampling process 8 more times for a total of 9 noise files. After the analyzer has completed the 9 runs, we use Microsoft Excel to retrieve the gain file and the 9 noise files and perform calculations to provide an average of the input referred noise for the two modules and then draw a chart. As a practical implementation, the AP Spectrum Analyzer is a gray box with analog outputs on the left and analog inputs on the right. 4 BNC cables connected to a shielded enclosure that will hold the electronics during test. A custom baseboard that holds the modules is connected to a battery board. The red power switch is used to disconnect the batteries when not in use. There are 8 lithium-ion rechargeable batteries that provide plus and minus 16 volts for the op-amps. The baseboard is installed in a small aluminum box with slide rails that places it above the battery board. Additional BNC cables are used within the enclosure to connect the pass-through connectors on the enclosure to the inputs and outputs of the board. The battery board is below the baseboard with the installed modules on top that can be seen here. The analyzer is controlled by a custom application file that will run the noise test 9 times. It is shown here before the test is started. When the software is started, it will offer a prompt to remind the user to set the configuration of the custom hardware to test gain. When the user selects OK, the software will use the embedded signal generator to send a small amplitude sweep of sine waves to the test set. The signals that are received from the test set are shown in the small window on the lower left. After the gain test is completed, a set of 2 gain curves are presented. The red trace shown is for the JFET enhanced TL071, and the blue trace is for the standalone TL071. You will see that the JFETs have extended the frequency response from about 10K to at least 80K. The results of this test are stored in a CSV file that has a list of frequencies and the corresponding gain for each channel. Now a prompt appears to remind the user to configure the test set for noise measurements. At this point, we disconnect the BNC cables and ground the inputs to the op-amps. Then click OK. Now the running sequence begins where the input range is sampled 10 times in a row. Each acquisition is added to the others to slowly smooth out the signal. After 10 acquisitions, the data is saved in a CSV file that contains a list of frequencies and the amplitude of the noise at that frequency. We use an Excel file to average the 9 noise runs, divide out the gain, and convert it to nanovolts per root hertz. We will run a macro that will open the individual files and copy the data to this spreadsheet. After a brief delay, the data is imported and calculations are completed. We can see the graph of the 2 channels. The blue trace is the TL071, and the orange trace is the JFET enhanced TL071. You'll note there is a substantial reduction in noise by adding the JFETs. A frequency often reported in the data sheets is 1000 Hz. If we zoom in at that frequency, we can see that the noise decreased to about 3.3 from 38 nanovolts per root hertz. Since there could be a difference between the individual op amps that were used, we can interchange the op amps in the two modules and run the test again. The results are as shown in this graph. The orange and yellow traces at the bottom show that the module with the JFETs outperforms the standalone op amps even when the op amps are swapped.